Okay, so this is notebook 5 on conditionals. And we start this notebook by talking about the basic syntax for a conditional statement in Julia, for which we use the if keyword, the else if keyword for additional conditions, the else keyword for our default option, and then our end statement, as with for and while loops, for example. Now the first example of using all these keywords that I will give is my implementation of the Fizzbuzz test. Now, for those of you that might not be familiar, the Fizzbuzz test is this commonly mentioned online interview question that novice programmers might get, where the idea is that I shouldn't say novice programmers, I should say programmers going in for a job to be interviewed. Anyways, the idea of the Fizzbuzz test is that you're given a number or a set of numbers, and you want a test that produces the word fizz if the number is divisible by 3, that produces the word buzz if the number is divisible by 5, and fizzbuzz if it's divisible by both 3 and 5. And so here, the number that we'll test will be 42, because that is my favorite number for obvious reasons. Maybe that's not obvious, but it's a Hitchhiker's Guide to the Galaxy reference, in case you're not familiar. Just being a little silly, but yes. So we will now test the number 42 with my Fizzbuzz implementation. Okay, so what we're seeing here is that we get fizz because 42 is divisible by 3. So how did we check this? Other than using this if, else if, else end syntax, some of the new things that I'm showing here are this double ampersand. This also could have been a single ampersand, but that is something we'll discuss later in this notebook. Either way, ampersand or double ampersand is saying and. So that means we're checking that both of these two conditions are true. As for the conditions themselves, this one is checking for divisibility by 3, and we're doing that by checking what the remainder of n divided by 3 is with the modulo operator. And then double equality sign here is what's checking for equality between 0 and that remainder. Otherwise, I think those are the only new constructs that I'm showing here. So next up, I really like to talk about ternary operators in Julia because I hadn't seen them before coming to the Julia language, and so I think they're fun and very clean. The idea of a ternary operator is that we can rewrite a conditional statement written with traditional syntax like this that I have highlighted here. If A, then B, else C, end. We can rewrite that as a one-liner, or possibly a one-liner, depending on how much code you have, as such, without using the if, else, or end keywords. So let's see what that looks like in practice. So I'll start with two numbers, x and y, which are 3 and 4. And here we have a conditional statement that checks whether x or y is larger. So if x is larger, it's going to return x. If y is larger, it will return y. Really, if y is larger or equal to x, it'll return y. And so in any case, we're returning the larger of the two numbers. Now we could rewrite this exact conditional statement with a ternary operator right here. And so what I've done is I've taken the conditional statement that's being evaluated right after the if keyword. I've thrown that in, and really I don't even need this these parentheses. And then we put a question mark after the conditional statement, so we're thinking, is that statement true? Question mark. If it is, do x, or return x, and if it's not, colon, then do or return y. And so we're getting 4 as above. So that is what a ternary operator looks like in Julia. And the last thing that we'll talk about in this notebook on conditional syntax is short circuit evaluation. So above, we showed that we could say and with a double ampersand like this. Now in Julia, we also could say and using a single ampersand. So for example, we could say, yeah, I don't really like that example. I'm gonna add some additional cells here. All right, so for example, I could say true and true, or I could say true and true. And those will generate the same result, as you can see there. Now what's different between these two different examples is that in the second example, what we're doing is we are short-circuiting our evaluation. So if, for example, let's say that this was the statement that I was evaluating. I'm saying false and true. So I want to see if both of those things are true. Again, we're returning the same result in both cases. But what's happening in this first case is that Julia is by default eagerly evaluating the statement. And so what that means is that Julia is going to see false, and then it's going to proceed and evaluate to see what the value of this second statement after the and sign is. In short-circuit evaluation, we terminate evaluation or we leave a statement as soon as we already have enough information to know the right answer. So in the case of false and true, as soon as we see our first false, we know that we could quit evaluation. And doing so would be more computationally efficient because then we're not spending time looking at whatever this second input argument to and is. And so with short-circuit evaluation, we're not looking at this second input argument once we've seen that the first input argument is false. Now, a place where we can see that there's something slightly different going on here is when we have statements like this. So, for example, if we say false and true with this high statement thrown in here, we never actually see high get printed, and the reason is that this statement has not been evaluated. In this case, however, we do see that high gets printed here because Julia has seen a true, and so it proceeds to evaluate the second statement. Similarly, if you were to say true or print high, this, because we're short-circuiting, we're never actually going to get to the point where we say print high here. And in this example, if we say false or print high, we will actually evaluate the print high, though I think this needs an extra Boolean statement to, oh no, it works just fine. Okay, great. Yeah, so that's the idea, that we actually evaluate this statement here because this is false, and not here because this is true, and that's with short-circuiting. On the other hand, just to again show you the difference, if I remove one of these vertical lines to say or with only one vertical line, and I run that, we're now printing high, though it's getting angry here too. Technically, I need a Boolean statement here for it to be happy. So if I do that, now we print high and don't get any error messages. Okay, so that's it for Notebook 5. We have